Okay, I guess it's start time for me. Hi, everyone. I'm Tiffany Jernigan. I'm a developer advocate at VMware. Actually, who's heard of a developer advocate before? Okay, like 2 people. Sweet. Yeah, basically it does stuff like speaking at conferences, writing blogs, interacting with the community, especially on my side with like open source and Kubernetes and whatnot. If you still use Twitter or X, as it's I guess now called, that's up there. And then for a bunch of other things like LinkedIn, et cetera, I have a Linktree as well. So yeah, you can probably figure out what I'm talking about production readiness. It's kind of why you all probably decided to walk in here in the first place. All right, so kind of giving a little bit of a background as to like why people actually care about production readiness at all. So for one, you need to care about like your users, the clients, basically the lovely people that we have in the corner over there. And the goal is to make these people happy. Because sure, you might have some application that's running and you like the application, but if people can't use it properly, if it keeps going down, if the people who you're trying to get money from or whatever aren't happy, then it's not really going to work out. So in order to do that, we need our services and our system to basically be as good and stable as possible. So that's where we have the little parts over there. So like this kind of gets us a little bit into like what is production readiness. I don't know that there is exactly some sort of like official definition for it, but I'm going to try to give it a summary at a pretty high level. So this kind of goes back to the picture a little bit ago. You can actually see it hiding in the back there. So this definition is not bound or scoped specifically to Kubernetes. It's a lot more than that. So basically it's saying the state of a system which is fully prepared and capable of running production workloads provides the level of service and performance required by its users. So there's even more detail when it comes to that. So this is one of 2 bulleted lists that are in this talk. The rest are a bunch of diagrams. This talk was originally created by my friend Matthias Helsler and I, and then we had that for KubeCon. Yeah. So like one of the essential things is the second bullet that we have there, and that is to ensure that things are reliable, that they're stable, that they're secure. This basically includes that it's performing well as expected, and even figuring out what's going on when unexpected things happen. So basically that it can go and adapt well to things that are changing, and figuring out like how to make it so that you can provide end users what they're expecting in the end. There's also things like being able to be monitored and observable. And then things like making sure that you have documentation, because a lot of the time you might go and try using some sort of application, and then there's just no documentation, you can't figure out how it works, and then you just decided you're done with it anyway. So prod readiness, of course, is a thing that exists outside of just the realm of Kubernetes, but since this talk is focused on Kubernetes and cloud-native technologies, I'm going to start going into things of what is provided in the box effectively with vanilla Kubernetes. So I assume it's going to be everyone, but who here has used Kubernetes? Okay. Most everyone, maybe everyone, and you just are too tired listening to me to raise your hand. That's fine too. So just to recap then, anyway, so basically at a very high level, Kubernetes runs and manages your container workloads. So say if you have like this application that you're trying to run over there, or maybe you could be like, hey, I want to run a bunch of copies of it, or I want to have high availability, and how do I handle this? And that's where Kubernetes comes in. For anyone who actually didn't raise their hand because they haven't used it, there's a QR code there for a blog for Intro to Kubernetes that I wrote. So basically, you can see from this here that you have a bunch of users, and then there's the pods that they're creating or they're interacting with. And Kubernetes has things like built-in basic logging. You can use the kubectl CLI to do logs. And then you can, if you have access to the control plane, then you can also have access to kubelet logs as well. So like, basically, Kubernetes is like a generic runtime. It's flexible and it's independent of like whatever workloads or what you're running. Basically, you can be like, hey, I want to have something that is Java. I want to have some random front end or back end or whatever it is, and it doesn't really matter. So basically, like the slide is saying, that it's a distributed platform for running, connecting, and logging your containerized workloads. So it's also flexible on the infrastructure level, so basically independent of the workloads, and you can be like, hey, initially I only had 2 nodes, I'm playing around, this is all I need, and now suddenly you need 20. You can go and scale up without having anything happen to whatever you're running. And as a result, you can also dynamically scale that back down. And as well, on the workloads level, you can easily go and scale up and down there as well. For instance, I could be like, hey, I want to run 3 copies of whatever my deployment is. And then you can do things like, oh, hey, I want to deploy some new version and do some sort of graceful migration. And then there's things that I'll talk about a little bit later that have to do with like fault tolerance. But basically, these are just like some of the things that you get out of the box with Kubernetes. So to look at a view of pointing out a few different things. So we have things like scaling, for instance, which I was just mentioning. So being able to scale up, scale down. There's load balancing. There's things like basically if you have a service and you have a bunch of different pods, it'll balance between those. There's things like auto restarts for fault tolerance. There's updates that you can do without just having downtime. So there's just like a bunch of different things that come by default with Kubernetes that help make your life a lot easier instead of having to do this all manually. So to just kind of give a little summary, so yeah, high availability and resilience of your workloads, gives fault tolerance, there's elasticity both of your infrastructure and of your workloads, and it's quite extensible as well. But that's only some things that you might need. So there's a bunch of stuff that are missing from just what one would call a vanilla Kubernetes. So to simplify things, this is a little like breakdown of categories that Matthias and I thought were pretty useful there are things missing in. So there's security, workloads, network, observability, and infrastructure. And some of these have overlaps amongst each other. Like something you could have that's networking might be also a tool that is used in observability or could be used in security as well. So if you're running Kubernetes, you have to provide some sort of underlying hardware. Maybe that's VMs in the cloud, maybe it's bare metal, maybe you're using a Raspberry Pi. It could be a bunch of different things. But with that, you need to care about things such as like backups, for instance, whether that is of like your specific workloads or your persistent volumes. You need to worry about like the availability of some of the managed services. Maybe you have some sort of like database and you need to worry about that, and maybe it's some sort of legacy one and you need to figure out how to connect to that to your Kubernetes cluster. So there's just a bunch of different things that you have to care about on the infrastructure level as well that are not specific to things that are directly in there with Kubernetes. So then also further on the side of infrastructure, basically like now that we have like the underlying hardware that we need, there's a bunch of other things like Kubernetes has API objects for storage. So for instance, there's things with like persistent volume claims and persistent volumes, but usually when you it has the objects for those, but you actually need some sort of like maybe some sort of cloud provider backed storage and being able to connect that. So it's something else that you need as well, and you have to provide it and make it so that the Kubernetes API objects can go and consume that as well. There's things that, like for backups, so maybe if it's of your infrastructure or your workloads. And then if you want to be able to like connect to things outside of Kubernetes, such as maybe some sort of database, you need to be able to make that accessible and available to the workloads that you have. So these are all things that exist partially in Kubernetes, but things that you have to do some work to make it actually happen. So then on networking. So like you have your application just running in your cluster. If you don't expose it in some sort of way, it's only useful to the person who has access to your cluster, which probably isn't what you want in the end. So maybe you want to do something like having an Ingress to make it so others can use it. So that's the Kubernetes API object. However, you need to have something like an Ingress controller, which is not there by default. And there's a bunch of different ones. There's ones like Nginx Ingress, there's Contour, but basically you need to go and figure out, hey, what do I want? And then go and install that and then have that interact with what exists in Kubernetes. If that doesn't give you the granularity of things that you want, then you could probably look into the like newer gateway API. I don't know too much about that one yet, since I've only heard about that one recently. Or you could do some sort of custom implementation using load balancers, for instance. Basically, there's not just like one like golden pathway for figuring out how to do actually a lot of these things. If you've ever seen the CNCF landscape, and if you haven't, I'll show it later, there's just so much there, and trying to figure out, hey, what of these different things do I care about and what do I want to use? So basically, there's a bunch of things, and you'll have to sort of figure out what works best, but you need something. So there are things like load balancing that are included. Not everything is needed for everyone, but basically maybe you might want to have some sort of like encrypted traffic between like two different services, or maybe you want to have some sort of like percentage routing. Like for instance, if you want here, you can have the 66% and 33%. You can't divide things like that by default with how Kubernetes is normally. Like you could have it evenly split, for instance, between the number of pods that you have in a service, but not like I want 20% here, et cetera. So that's where service meshes come in to help fill that gap, to let you do things with things like the encryption or to do percentage routing and whatnot. And depending on what you might need, that also might be a bit overkill. It's just a thing you'll have to look into. So for traffic control, so we have things like network policies. They exist as a concept in Kubernetes by default, and they're used for isolating traffic, but basically you have to create them, and it will deal with things like with encryption between workloads. Then you could do things with advanced routing, such as with like HTTP headers. So there's just like a lot in the realm of just like networking of things that you need to do to be able to make it so that your applications can be production ready. So from networking, the next part that is nearby is observability. Actually, there was a study that had been done by, I believe, Cilium, where they were asking what is the most important thing to you for having a service mesh. So there was a bunch of stuff that was related to networking. There was routing, there was rate limiting, and things like that. But the one that actually was at the top of the list was observability. So it's kind of cool seeing how some of these tools can help you out in a bunch of different ways and not just for one thing. So like as mentioned a little earlier on, there's basic logging by default, so using kubectl logs, which tells you some stuff, but if your container goes away, then it's not really easy to go access the logs anymore. You can also get some basic like metrics if you have metrics servers set up, but that's again something that not like if you're using a cloud provider, some of them have metrics server like set up by default, but it might be something that you actually have to go and add. But that's not really enough. So if you want to do things like exposing your workloads, you kind of have to know what is actually going on. So Kubernetes itself doesn't actually have a monitoring stack. You need some way that you can actually go and persist and visualize the data. So be able to get specific metrics from somewhere, being able to see, hey, okay, suddenly this, maybe this pod failed at this point in this deployment, or maybe just everything crashed at a certain point, but being able to see a visualization of what is happening. Otherwise, just getting a bunch of numbers is only so helpful. So that's where you might want something to deal with like connecting with like metrics and then being able to see traces. There's things like Prometheus, Grafana, and Jaeger for trying to look into some of those things. Later, I'm going to go into like list off and talk a little bit about some of the different toolings that are out there in each of these categories. They aren't the only right ones because that's just not a thing. It's just the ones that I have some familiarity with, or that maybe VMware has some relation to, but they're all open source. So on the side of security, so like one of the things that you could have is like at a very basic level is some sort of namespace isolation. So for instance, you could give someone even admin access to their own namespace where they can do whatever they want in that namespace, but you don't have to worry about them messing up like your production workloads or anything else. And then, I mean, maybe you actually have your production workloads running on an entirely different cluster or on an entirely different VM or whatever, just however you decide that you want to separate things. And then if you're having things in production, you probably should not have it where anyone really has kubectl access directly to be able to do something with it besides whatever CI/CD you have set up. You don't want someone to easily just be able to do like a delete on some sort of deployment that's super important. Or maybe you start running things that shouldn't be there because someone decided they hate the company and they had a bad day. So they start running things. But then there's also the side of authentication and authorization. And we have things with like certificates, there's OIDC tokens, you can have service account tokens, and then like, I guess several versions back now, I think it was 121, they added bound service account tokens. So once the pod that it's associated with goes away, then you don't have to worry about the token sticking around, because before it would create a secret when you created a service account, and that would just persist. And then, so with RBAC, you can be like, hey, I want to make it so this person can only view everything in my cluster, and that's it. And then just give different rules and permissions based on that. And then there's also tools out there that allow you to check what kind of access people have. And then there's also PSS and PSA. I keep forgetting what the second S in PSS stands for, because everyone always calls them by acronyms. But I think it's Pod Security Standards. And OK, it disappeared on that screen. And Pod Security Admission. So basically, like, it used to be Pod Security Policies, and then that got deprecated. So there's just some changes in that space. I think that QR code is for a intro security blog I wrote. I'm not 100% sure still, but it should be. OK, so like, we haven't really looked into detail for things on like the side of the workloads level. We've been looking at things on like a lot more of the infrastructure, for instance. So like, in the end, the people using your stuff, they don't actually care where it's running or like what language you wrote your application in. Well, some people might. But in the end, like, it's a combination of like what is running on your system overall, and then what you're actually running on that, and the workloads, and just like how well do they work? Is it doing what they want? How fast is it? Does it seem secure? Does it do what they expect the application to do? Does it keep going down? Things like that. Basically, like, if you harden your cluster in the best possible way, but you're still failing in your workload aspects, then it's still not good. So how do we cover those aspects? Like, how do we ensure that they're stable, that they're secure, and that they're observable? So over on the left side here, we have these developers, and on the right, there are the consumers. So like, the question is, like, how do we get from one side to the other? So a big thing is to have automation so that things can be repeatable without having manual steps, so dealing with CI/CD. So there's a bunch of different tools out there that are, like, for instance, in the GitOps space, which I'll be showing in the next slide, that basically helps make it so this is a thing that you can just be like, hey, I'm going to run this today, and it's going to be the same thing as I run tomorrow. So there's things that you could have, for instance, you could have GitOps with like Flux and Argo. You could have just general CD things. There's tools to help with packaging in YAML, for instance. So there's Kustomize, there's the Carvel tool suite, which has YTT, and then there's also Helm. And then there's things with supply chain security, and you can see that you actually need to worry about security on every single step of the way. So it's not just one part and caring only about that one part. So this is a summary of all the things we looked at. It is meant to look this chaotic because basically this is all the things that we were looking at, and there's just really a lot of stuff that isn't already there that you have to worry about when trying to get your cluster to be production ready. It's not just chaotic visually, but it is when you're trying to work on this. So especially if you're like maybe a single person trying to do something with all these different aspects, it can end up being a lot. So to kind of simplify it again, we're going back to this, where there's the like different problem areas of things to care about. And this is a little checklist. This is not obviously the one and only checklist, but this is one possible option of things to start looking at and caring about in those different categories, such as maybe specific things with logging, things with tracing, service meshes, network policies, maybe secrets manager of some sort, and then backups depending on what is applicable to you. So just kind of things to maybe start to consider. So if you hadn't seen the CNCF landscape before, here you go. Basically, there is a lot here. There are so many different tools. There's things that have moved through, like graduated and incubating and all that over time. And then there's a bunch of new things constantly being added. I don't know if there's a single person that can describe to me every single one of these. And if you can, please help me learn more. But I'm going to go into some of the things that some of the others and I have, like some other people and I have looked into a bit and can actually talk about some. And they aren't, again, the only right choices, but they are some options. So for infrastructure, there's Cluster API. And so Cluster API, you can use, it creates CRDs to create cluster resources. There's Valero, which you can use for backups. So you can back up the workloads that are running on your cluster as well as the persistent volumes. Those two are specifically focused on Kubernetes. Then we also have Terraform, Pulumi, and Crossplane, which are like infrastructure as code, and they can then be used to create Kubernetes infrastructure or a bunch of other things like AWS resources, et cetera. On the network side of things, so for Istio and Linkerd, we have a bunch of things over on like this side of service meshes. And again, that's more than just networking. It's also security and observability as well. There's Cilium, which is based on eBPF. So like the most common service mesh is having a pod as like a sidecar pod as a proxy. And you have that running in every single one of your, or having a container as a sidecar proxy in every single one of your pods. Whereas with eBPF, instead of running inside of your pod, you have it running on each of your nodes. So that basically interacts with the network on a node level, like in the kernel space, and it can do things like service mesh and observability, et cetera. Then there's Entrea, which implements CNI and the Kubernetes network policy, and that gives like things like network connectivity and also security for pod workloads. So then in observability, we have things like Jaeger for distributed tracing. There's OpenTelemetry, which is just like a standard that uses a bunch of other tools actually within it. There's Kiali, so you can actually visualize things with your service mesh if you're using Istio and actually see what like traffic is going from this direction to that direction and the percentage of errors and things like that. There's things like FluentD with logging. In security, there's things like OPA, Caverno, so that's policy-based control. We have Cert Manager, which is kind of self-explanatory, manages your certificates. There's things like Spiffy Inspire, which is for identity. There's Intoto for supply chain integrity, and just a bunch of other things there. And then this is where the point is where we're actually going and leaving the cluster, going back to workloads. And so there's things like Flux and Argo, which is a continuous delivery, so that's part of the CI/CD pipeline. And then there's things like Helm. There's parts of the Carvel tool suite and such that are used for packaging. There's also build packs. Who here has heard of build packs? Okay, not very many people. So basically, instead of having to write a Docker file and be like, I want to do this and this and this, basically you're like, here's my Java code, here's my Go code, cloud native build packs, figure out what language this stuff is in and create an image for me. So if you go to buildpacks.io, you can learn more about that. All right, so now what? So this is a semi-old suite now because time has just gone by fast in the last few years, that by Kelsey Hightower, who basically said that it's your responsibility to purchase, staff, patch, scale, and upgrade. And if you're just dealing with all these things, that's a lot to have to keep in sync and can just end up being pretty chaotic. So then this is like one example of a breakdown. The little dots mean that there could be other things in between. So this isn't exactly an official definition, but basically all the red stuff is things that you manage. All of the green is what some sort of provider might manage. So unmanaged, obviously, everything is you. For managed, you have the provider doing infrastructure, hardware stuff, and managing Kubernetes. And then there's one that we're just calling fully managed, which is an official terminology, but where they're also dealing with things like security, networking, and observability as well. There isn't necessarily a right or wrong. It just kind of depends on what you need and how much information you might want. For instance, if you have some reason I have to see my control plane, then you probably can't use some sort of managed offering since I don't know that any of them actually let you do that. So it's just kind of trade-offs they have to figure out. So this is an example for Tanzu Kubernetes Grid, just kind of showing like how they decided to bundle a bunch of different products. So a bunch of these you might have recognized from some of the other slides. Again, this is not the only way to decide I want these ones, but it can help you figure out maybe how different things might work together. And then maybe you can have your own different thing where you pick ones and decide to put those together as well. So then there's a question of like, do you want to be on-prem or do you want to be on the cloud? So my thought process basically is that you probably want to be in the cloud unless you have things like lots and lots, maybe like thousands of bare metal just hanging around because, I mean, that probably wasn't cheap the first time you bought it. Maybe you have like super sensitive apps, so maybe it's like something military, something medical, nuclear, or whatnot. And the next question is there some sort of managed offering that is approved by your country that allows you to use it for that? If not, then you need to go to on-prem. And then just kind of like, there's just a bunch of thought process you need to make of like deciding, hey, is there a reason that I need to do one versus the other? And if you, for doing it on the cloud, you obviously don't have to go buy a data center and then have a bunch of VMs and store that there. And then there's a question next of, do you want to do something like managed or have it be self-hosted? So like basically, managed is where someone is going and running things for you. So basically, some of the reasons that you may not want to go and have it be managed is if you're running on-prem. There are some offerings out there that can help you do with that, but it's still not the same as when you are doing like a fully managed version. If you have like some sort of huge cluster, which has maybe thousands of nodes, and your cloud provider doesn't have the ability to do that, so then you, again, wouldn't want to. Or maybe you need some of the super new, shiny Kubernetes features and want to enable them and can't really do that since a lot of the times the managed offerings are not exactly at the latest version as soon as that version comes out. And then just like the blanket version of the you tried managed and it just didn't work for you for some reason, so well, then I guess try to have self-hosted. So this is another quote from Jerome Petazzoni, who created the title for this talk, actually, and gave a bunch of feedback. But basically, he said that the fastest, easiest, and cheapest way to run your Kubernetes clusters is to get someone else to do it for you. So that's something to consider. So to kind of just like summarize things a bit, in the end, like the goal of this is to show you that there's quite a bit more than just putting your apps in containers and writing YAML. I mean, there is a lot of YAML writing, which is why I guess there's a bunch of tools out there to help you templatize it and not have to write a bunch more. There isn't any like right or wrong for honestly any of these approaches. It just kind of depends on where do you want to invest your time and money. Do you want to invest the time in just like you're working on your applications and the money into those engineers? Or do you want to have engineers that are also dealing with keeping up the infrastructure and then buying the infrastructure and whatnot? It just all depends on specifically what you need for what might work for you. Maybe you want to maintain the entire stack yourself and invest money into that and have it in-house for some reason. Or maybe you just are like, okay, I don't want to deal with this. Please deal for me. Here's some money. I assume you're going to keep my stuff up and running. Otherwise, I'll take my money back. But yeah, you all have to just decide for yourselves. But basically, I feel that you should go with the highest abstraction possible. Try to not just do something that someone else has already solved. And because with this, it gives you more time to basically work on your applications instead and not have to hire a bunch of other people to do something that someone has already done. So this photo is me again, sorry. And then this is Matthias. If you want to ask him questions about stuff, he's done a bunch of different things on the side of Cloud Foundry, Kubernetes, and then Spring and Java. So we have a talk. We did a 3-hour deep dive on Tuesday at DevOps in Belgium on observability, if you are bored and want to look at observability for 3 hours. Or you can watch his talk from DevOps UK that was 50 minutes, which is shorter. But there's just a bunch of different things out there. So yeah, thanks for coming to my talk.